Good morning, students. How many of you have done MCQs? In chat window, you can respond yes or no. Oh, good. Only one student? Okay, can you quickly tell me the answers? One by one. What is first? Yes, students. By which kind of hardware components make cloud computing cost effective at the time of building resource pools? What is the answer? The answer is commodity hardware. Then resource pools are organized in hierarchical structures. If you have any doubt, you can ask. Traditional approach of having discrete and independent set of resources is known as traditional one. I think none of this. Resource pool at cloud data centers are created with commodity hardware components. Multi-tenancy in cloud computing is powered by ownership of free resource sharing, temporary resource allocation in virtual mode, so all of these. In cloud computing, resource provisioning to consumers are made through virtual machines. In static provisioning of resources, resource allocation decision is taken. Static means before starting of application. In dynamic provisioning of resources, the resource allocation decision can be taken after starting of application, on demand, for number of times. So all of this. Dynamic resource provisioning approach eliminates the problems of resource under provisioning and resource over provisioning, both. So A and B. Zero downtime system architecture is outcome of, uh, resource pooling. Standardization of cloud environment is done over virtualized resource pool. Any doubts in this? Okay, so let us go ahead. Today's chapter of discussion is scaling in the cloud. Can anyone tell me what do you mean by scaling? What is the meaning of scaling and why is it necessary? Hmm. Um, Students, scaling is one of the important characteristics of cloud. So you can say that it is a very important feature or characteristic or property of cloud. Like virtualization. If you remember, virtualization is the foundation for cloud. It is the key enabler of cloud. Likewise, scaling is also another feature in cloud. What is the meaning of scale? Scaling means increasing or decreasing, means a system. Here you have cloud. In the cloud, you have resources. User can request for the resources and user may need to expand the resources which have been allocated, or user may prefer to shrink the resources that user has already obtained from the cloud. Both the cases, the system is termed to be a properly scaled system or not. You can call a system, uh, a well scaled system when you are able to do both the tasks effectively. As your demand increases, you obtain new resources, extra resources, or expand the system. As your demands go down, the system scales down or shrinks. Let us take an example. If user has obtained two processors and 500 GB of memory, this is the user system in the cloud. All right. Today, for instance, today user has obtained these resources, and after few days, consider after 10 days, user feel that user needs only one processor or uh, 200 GB memory. This is present scenario. Okay, and then you have this one future, or in future user may go for three processors and 1 TB memory. There are two cases that may happen over a period of time as per the demands and requirements. When this user has this resources from cloud, means this is the system of user in the cloud. User wants to scale up, means expand or grow, right, to this, then it is possible in cloud computing. On the contrary, user wish to shrink or decrease or reduce the resources. This is also possible in cloud. Both these qualities is termed as scaling of a system. Okay, I hope it's clear. So scaling is the ability to grow or shrink. It is a characteristic of a system. And scaling also could be termed in cloud as the increase or decrease in the workload. User submits workload to the cloud. User system is this, and user has submitted 5 applications to be executed on the cloud. And sometimes user may have to increase the workload from 5 to 8 applications. Perhaps may decrease to 3 applications. This is the workload that is submitted from the user to the system in the cloud. This can also expand or shrink, grow or reduce. So the property is system should be able to scale well, and its level of performance or efficiency should not decrease. If user has submitted 5 applications and these applications are being executed in 1 second, and when user increases the count of application to 8, if the performance and the efficiency remains same to be 1 second only, then system is properly scaled. Its its functionality has not been degraded due to the overworkload. And system is able to do scaling properly. There are two aspects here, because resources can be allocated dynamically or statically. Statically, a user in advance request the resources. Okay, these are static, these are fixed. User cannot add or delete. Um, During execution in this static mode. So because it cannot be done during execution, what a user is supposed to do is shut down and restart the system if system has to be scaled in this mode. And on the contrary, if it is a dynamic resource allocation or provisioning, if it is dynamic, then during the execution, the resources or workload can be added or can be removed. All right. So this point is scaling is a very important attribute of cloud computing, and scaling in cloud is dynamic. Dynamic automatic scaling. What happens is system resource capacity can be altered while system is running. This is dynamic scaling that enables system to keep growing or shrinking during times, okay, by expanding as per the demand grows. And the other property is that the system in a cloud has been expanded, for instance, and later user realizes that is user would like to restore to the previously allocated resources. In that case, system should be reversible. Reversible in the sense that whatever resources have been allotted, those have to be, taken back by the cloud. So that is allowed in the cloud, and it is possible that resources, the system state can be restored, can be the capacity can be increased or decreased, and the state is reversible, and it is perhaps dynamic. Dynamic in the sense that during the execution only, if user realizes that um, user does not require more resources or user requires more resources, both the decisions can be taken in a dynamic manner, in a dynamic scaling environment. Dynamic scaling. And um, here this upward, there are two concepts here: upward scaling and downward scaling. Upward scaling is about expanding. Downward scaling is about shrinking. And both the scaling should take place without affecting the performance and the efficiency of the system. Okay, that this is scaling in cloud is reversible. And foundations of cloud scaling. Cloud scaling is dynamic and automatic. What do you mean by automatic? As the consumer specify, or sometimes without specifying based on the workload, the capacity would be expanded. Okay. So what happens is you have submitted a job or an application to the cloud with the capacity, required capacity to be 3 GB. However, while executing, more 2 GB data has been added. So now your system should allot 5 GB. Actually, it was allotted 3 GB. But during execution, 2 more GB data is come up, and it has to be accommodated. In auto scaling mechanism, user need not specify. Based on this, user will cloud will automatically increase the limit to 5G. So this is auto scaling facility. All right. Example which I can give is array and linked list. If you remember array and linked list, array is static, and allocation of array for 10 elements will retained to have 10 locations. When you are using only 3 locations, it is under provisioning. When you would like to use 15 locations, it is over provisioning. That's why you have gone for linked list, where fixed locations are not defined at the time of creation. If you have to add an element, you add one element, one node will be created and element is added. If you have to add another element, another node is created and element is added. Likewise, it continues. And as soon as you start deleting, you delete, for instance, nth element, so the location for nth is released. Now linked list no longer has that node n stored at that memory location. It has been deleted, and memory has been relinquished. All right. Like this type of concept is implemented in cloud. And what makes cloud so dynamic? There are 3 features: resource virtualization, resource sharing, and dynamic resource provisioning. Due to these 3 features of cloud, auto scaling facility can be implemented. How it can be done? Through resource virtualization, resource management tasks have been simplified. User access the physical resources through a layer known as hypervisor or virtual machine monitor or hypervisor. And every user has been given a virtual machine. So the task of physical resource management has been simplified to a great extent. Next feature is resource sharing. Resource sharing is also the core of cloud. If there is no resource sharing, there is no concept of cloud. One physical machine has been allocated to, say, 4 users in the form of 4 virtual machines. Underlying, there is only one physical machine. However, this has been made as 4 machines through the virtualization concept, and you achieve resource sharing through this concept. This resource has been shared by virtual machine 1, 2, 3, 4. All of them are sharing this. If there is no sharing, what happens? Every physical machine has to be allocated to each user. Then that commoditization and billing, metering, and effectively utilizing the resources would not happen if there is no resource sharing. Now, for instance, let me give you one example. I have a laptop. Presently, I am taking class in my laptop. It is in working mode. Later, after 1 p.m., for instance, I get some work, I shut down the laptop. Then what happened to that resource? Resource is inactive. Resource is not in use. So if I introduce the concept of sharing, I might give my laptop to someone else, my neighbor or my friend. Whenever I am not using, that particular person is using. And then we are sharing. All right. And the third one is dynamic resource provisioning. Dynamic resource provisioning is uh, about requesting for the resource on demand. For instance, you are going from one place to another place, from source to destination. You call a two-wheeler. You book a two-wheeler on Uber and Ola. We can book even a two-wheeler. So you book a two-wheeler, and suddenly what happens is two of other friends arrive at your place. It was not informed to you that they would be coming. They suddenly come up, and then you three now have to go to this place. Then what you have to do? You have to scale up your request. Earlier your request was a two-wheeler on a bike. Now what you have to do? You have to change this as per the demand. Now the demand is three people have to travel, and to do that, bike is not adequate to carry three. You have to book a cab. So now this is the demand of that situation. And as per the demand, if you are Uber or Ola or whatever, uh, you know, on whichever company you have booked, if it allows you dynamic resource provisioning, what you can do? You can say that I am scaling up my requirement from bike to cab. If dynamic resource provisioning is allowed, if it is not allowed, you have to cancel this, pay some amount, for instance 50 rupees, and then book a cab. This is not dynamic. This situation uh, is clearly evident that it is a static. You are not able to scale up on demand. All right. So these are the three features that enables scaling feature totally automatic. Okay. You can look at this figure. This is physical resource pool. Here you have processor, memory, disk, networks, networking devices. All these occur here, and these are the three pillars on which scaling, auto scaling, has been made possible. Okay, we discussed all these concepts. All right. The two other important decisions that cloud has to take for this auto scaling are capacity planning and load balancing. In future chapters, we will be studying in detail about capacity planning and load balancing. But these are also the two important decisions that need to be made by the cloud. Also, these are the factors that affect your auto scaling. If capacity is not planned, I can give you an example of bank here. Bank, every day when the bank gets open, they have certain limits and certain planning. They put out some amount of cash with the cashier, and this cash, what is made available to the cashier, has been decided based on some sort of planning, like every day a saving account can withdraw this much amount, current account can withdraw this much amount. Like this type of certain limitations are there, and based on the everyday's transactions, bank can plan ahead how much cash to be uh, put at cash. So like that, cloud system must also do capacity planning and load balancing. Capacity planning on regular basis. Every day, the system has to be analyzed. How much of resources have been used and how much of resources were requested and were on demand, and how much mm, was shrinked due to um, users request, and how much data is being processed on each of the machines in the cloud. If this machine, machine 1, this is machine 2, this machine is processing or executing 1 million apps, applications or processes, and this one is doing only 10,000. Look at the difference between two. And this system is not balanced. Apparently, M1 is overloaded, M2 is underloaded. This type of um, parameters, values, decisions, planning has to be made in order to implement on-demand and automatic scaling. Scalable applications. So what are the scalable applications? Okay. Okay. Actually, I would like to show you here uh, how this in cloud we can perform the things. All of you students, try to execute a program today on Colab, Google Colab. This is a cloud-based platform to execute programs. Okay, let me first give you a brief overview about Collaboratory. Google Collaboratory. This is a cloud-based Google service that allows you to execute Python programs on the cloud. And if you look at here, these programs are arranged in the form of cells. You write program like cell in the cell, and you have two types of cells: code cells and markdown cells. Markdown cells are like textual cells, code cells that contain the Python code. And this cell can be executed using various ways. I'll show you how. One is by using play icon, another is control plus enter to run the cell in place, shift enter to run the cell and move the focus to the next cell, and alt enter to run the cell and insert a new code cell below it. So there are four ways. Just by clicking on the play icon at the left side of the cell, here you will find left icon, play icon, and you can press control enter to run the cell, shift enter to run the cell and move the focus to the next cell, alt enter to run the cell and create a new cell immediately below it. All right, please remember these. And look at this. This is a cell. This is the play icon. When you uh, click on the play icon, it just rotates because it is executing. And we got the result here. Because we initialized A as 10 and printing A, with the print statement also you can directly print the variable. You get 10. If I change this value to 20, I get 20. This is executing. This is one way. I have pressed for the 2 times, I have pressed uh, this play icon. For the 3rd time, I am using control enter commands, control enter. Look at this. The cell executed in place. And next I am doing shift enter. Look at here, cell executed and the focus switched to the next cell. Now this cell is highlighted. And the last one is alt enter, uh, cell is executed and look at here, a new cell is created. And if you observe here, some resources have been allocated. This is an active session now. I am in active session. I have this as active session. I can get, okay. It shows, let me try once again with another program. This is text cell, also known as markdown cell, and adding and moving cell. You can add a new cell by using the Here you will see plus code plus text. Here plus code means you are adding new cell for writing code, plus text you are adding new cell for writing text or markdown. All right. And here for every cell you will get this menu. You can move cell up, you can move cell down, you can attach, you can edit, you can copy, you can delete for every cell. Working with Python. Um, so Collaboratory has been built on top of Jupyter Notebook. If you have installed Anaconda, you get Jupyter Notebook. So this Collaboratory is a cloud on top of Jupyter. So same functionality you observe here in Collaborate. If you want to interrupt the execution, you can press Ctrl M. Um, that is the hotkey, and you can go to runtime, and also you can select interrupt execution uh, command, and then exceptions. If there is any error, exception will be shown. If you would like to know about a function, you have to press shift enter. If you press shift enter, what happens is you have to add a question mark first. Random is a function. So to know more about this function, type the function, type question mark, and press shift enter. Then you will get, okay, because this is introductory um, notebook, all the features are not being enabled. I'll show you all the features in another notebook. But this is how error is displayed if there is any exception. And yeah, I suggest you all to start your Anaconda and Jupyter today only, because it's very fascinating. You can print lots of graphs, different charts, and different ways of visualizations you can perform. And even you can embed audio, video in this notebook. There are a lot of things to be done. And integration with Drive. Google Colab is integrated with your Drive, Google Drive. So whatever you store in your Google Drive, you can open in Google Colab and you can execute. And you can make a copy if you are um, opening from some other source. You can save it, and you can save and checkpoint, so that you can go back to that particular point, and you can look at the revision history, how and what changes you have made to the particular notebook. It's known as Jupyter Notebook. You can comment on a cell. You can add a comment by clicking the comment button in the toolbar here in the toolbar. And you can right click a text cell and select add a comment, or you can use Control Shift M to add a comment. Comments can also be added, like you can add in Java language and C++. You can add comments, slashes, and slash star, like that. This is um, your Google Collaboratory. Look at here. This is copy to drive. This I can copy to my drive. This is database. You can upload data sets. This tab is related to data. This is uh, attaching drive to this collab. This is uh, all the folders probably. This one you can upload the file on the drive, which can be made accessible to the uh, notebook. So collab.research.google.com. I will open one. I have done one program. Uh, this program is okay. Connect. You have to connect. If you are connecting now, your processor, memory from cloud will be allocated. This one I will terminate, and this one okay. Collab Pro is paid service. It is available only in US. Then you get faster GPUs, longer run times. Like this is pay and use. Okay. If I hover the mouse over, I am shown connected to Python 3 Google Compute Engine backend GPU, RAM 0.79 GB of 12 GB. Actually, allocated RAM is 12 GB. To me, the free, it is for free. Free service is 12 GB RAM, 12 actually 12.72, and disk is 30 GB. No, 64 GB is allocated. Oh, I'm using 30 GB out of 64 GB. So 68 GB is allocated to me, and what I can do is here, um, where is it? I can change the settings. Hosted runtime is the cloud service. They are providing a processor, memory, disk space, and here I can change runtime type, right? Actually, in Kaggle we get here. I'll show you one more. Kaggle. Kaggle also gives you, uh, this is my account, cloud storage and processing free for limited. I have created some notebooks, and these are my notebooks. I will execute one notebook and show you. If I press this edit, this runtime environment will be opened. Here, if you see, this interface a bit different, but both provides a free cloud computing service. Look at here. I can use GPU, I can use TPU. Right now, my session is not using GPU, graphic processing unit. It's just using normal uh, processor. And here I get session metrics. 20 MB disk out of allocated is 4.9 GB. CPU I am not using currently, and 16 GB of RAM is allocated. I can use that. And 9 hours session. I can have 9 hours session. Okay. What does it means? At a stretch, I can execute these programs for 9 hours in one session. And here you can see HDD, CPU, RAM. I can stop the session. I can restart the session. I can ask for GPU because GPU is limited. And by default, only processor will begin. Uh, if I have to execute a compute intensive task, what I do, I use this GPU mode. Now, turning on GPU will reduce the number of CPUs available and will only speed up image processing and neural networks. And availability is limited to 41 hours this week because I have already used it. Quota resets weekly with a minimum 30 hours provided. You have 40 hours remaining. Okay. So every week 30 hours of free GPU will be provided, and I'm doing this neural networks program. So I can turn on GPU and look at here, I get accelerated GPU and GPU quota out of 41 hours left. This timer has started. Look at here. We have been discussing in cloud timer, this billing, because it is free. Means I have free account here. I can go for pro as well. Then this limit will be lifted. I can use as much as I require by paying the amount. So this here, look at here, 0 minute. Here this shows how much of GPU time I have used. All right. And I am using right now Python language, and Kaggle supports R language as well. You can execute R programs also on Kaggle, and I can execute this. Shift enter, shift enter. Shift enter is to execute the current cell and uh, move the focus to the next cell. So this is a machine learning program. I am training data. This is the input. I have added the input. These are some images, image processing. And if I use GPU, it is super fast compared to CPU. However, because this one does not require GPU, only CPU it is showing how much um, uh, a resource is being used. Everything is billed, billing, and but because it is free, I am not given any bill. Rather, my time will get added up as I use the resource. This timer will look at here. Now it is 1 minute. I'm using 1 minute. What I'm using since 1 minute? GPU. Okay. I can save the version. I can create number of versions. So actually I have not made any changes, but to show you all, I'm doing all these things. The version will be saved. I can access it later. You can do very good programming, very good projects on this Kaggle and on Colab. You don't have to join any institute, on your own you can do. So much resources are available for free. You don't even have to pay. And there are so many websites that are giving extra packages for students. If you prove that you are a student, then they give you that Amazon Web Services also 1 year free service it is giving. I showed you, but there it is asking for uh, bank details, card details. As far as I know, there is no risk. If you don't have much balance in the account, you can give and you can start working on cloud AWS. What I suggest you all is you create account, and if you have an account, bank account and card, where you don't put a lot of amount, you can specify that and you can use it. This is Kaggle, kaggle.com. So all of you today create your accounts on Kaggle. This is my account I have created already, and I have so many notebooks. I work so much on Kaggle, and Collab also I work. And this Collab here, runtime, change runtime here. Collab is also providing none means normal processor, GPU means graphic processor, TPU means um, TPUs are I have not used. They are faster than GPUs, and this TPU stands for tensor processing unit, I suppose. I think it is tensor processing. I'll will see once. Tensor processing, yeah, it is tensor processing unit. Tensor processing unit is an AI accelerator application specific integrated circuit developed by Google specifically for neural network machines. And Google Cloud is providing cloud TPUs. This is nothing but Google Cloud's TPU, tensor processing unit. Um, I am not using any accelerator. Accelerator means this is like scale up. Just now I showed you, scale up. This is normal. This GPU is scaling up, means higher processor. TPU is more higher processor. This is scale up, and then I can scale down from TPU to GPU, scale down from GPU to processor, further scale down. I can execute the programs. Here some data set is downloaded. This is a machine learning program for image classification. Dogs and cat image data set is there, and it will classify in the image. Look at this. These are different images on which this machine learning model has been trained. And then actually it is a deep learning model because we have here convolutional neural networks. And then we are processing the data, and we find out whether a particular image is cat image or dog image by testing. Okay, so students, today you have to execute a simple program on Colab as well as on Kaggle. Colab, I think directly you can access, as you all have Gmail and G Drive. You don't have to do anything extra. However, on the Kaggle, you have to create your account. Okay, so this is all about today's class. Tomorrow, I can't say when I would be taking class because I have exam invigilation duty tomorrow. I will inform you. Tomorrow it is dynamic class, not a static, like today. today it was a static allocation because you received the mail and also it was sure that the class would happen at 10. However, tomorrow it is down, totally dynamic, and I will let you know whenever I'm free, whenever I get time, and I'll take class. And tomorrow, all the students, please complete today's work and execute any simple neural networks program, or even this dogs cat classification program is available on the internet. You can take it and you can execute it. Any doubts, students? So, bye for today.